Good evening to one and all. We shall discuss now, in this today's lecture, we shall discuss the second part, that is kinematics of a particle. Actually, this is the second unit from this mechanics second or dynamics, and in that second unit we shall study the kinematics of a particle. समता ओहळ, रुपाली धाबेकर, ऋतू महाजन, बाकीचे स्टुडंट नाही आले का? Now see here, in this second unit we have to discuss the introduction regarding kinetics of a particle. Then we have to discuss the Newton's laws of motion, then the deduction from the Newton's laws of motion, then matter, mass, weight, linear momentum. That means these different concepts which we have to study in this unit number second. See this. We have to discuss all these points. So we shall start in the introductions here. We know that in the first unit, actually we have seen the part of a kinematics. See this. In the first chapter, we have studied the kinematics. Kinematics means in which the motion, motion of a particle, velocity, acceleration, all these concepts which we have studied under the geometrical aspect without considering the force which is a cause for the motion. See this. In the kinematics, we have studied the motion of a particle, in that particularly displacement, velocity, acceleration. These concepts we have studied in the branch of kinematics in the chapter first. In that case, we have considered these concepts only by the geometrical aspect of a motion. That means without considering the force. Okay, without considering the force which is a cause of a motion. Now in this second chapter we shall discuss here, in this second chapter we shall discuss the kinetics of a force. Kinetics of a force means which we have to study the motion of a particle due to the effect of a force. We shall study the motion of particle due to the force. That means we have to take here the consideration of the force. यहाँ पे आपको क्या करना है? फोर्स कंसिडर करके ही मोशन की स्टडी करना है. यानी कि काइनेमैटिक्स में ज्योमेट्रिकल एस्पेक्ट होता है और डायनामिक्स में और काइनेटिक्स ऑफ अ पार्टिकल में effect of a force which we have to study here. First of all, I shall write these concepts here, then you will understand the very well. 1 minute. See here. We know that the kinetics One minute. First of all, we shall discuss the kinematics. The kinematics that is the motion. Kinematics that is the motion of a particle that is its displacement, velocity, acceleration under the geometrical aspect, under the geometrical aspect, see this, under the geometrical aspects of the particle. That means without considering the force caused on the motion, that is without considering, that is without considering the force which cause of the motion. See this, this is a basic concept you must know. In the kinematics, we have studied the motion of a particle. In that case, we have studied the displacement, acceleration, velocity under the geometrical condition of that particle. That is without considering the force which caused that motion. Now, in this second section, we have to study the kinetics of a particle here. Now, in this second section, we have to study the kinetics of a particle. So, kinetics of a particle. Kinetics. Now we shall study the kinetics, or particle म्हणायची गरज नाही, मी फक्त कायनेटिक्स डिफाइन करतो. तेवढं डीप मध्ये कायनेटिक्स ऑफ अ पार्टिकल म्हणायची सुद्धा गरज नाही. 1 minute. Kinematics, this is the kinematics. Now kinetics. In this case, we shall study the effect of a force. In this part, we shall study the effect of a force. Effect of a force on the motion of a particle, on the motion of a particle. See this, and it forms a new branch, and that branch is also called as classical mechanics. Motion of a particle under the consideration of a force. This is another branch, and it is also known as classical mechanics, and it is started by, which is actually, this is the part of a dynamics basically, or at the origin the astronomer as like Kepler, Galileo, and the famous scientist that is Newton have done the series of experiments and observations. The Newton's law formulated, and there the 3 well-known laws of motion, and that branch is also called as the Newtonian laws. Okay. Now, which gives the relationship between the Newton's law, gives the relationship between the motion and force. So, the laws given by the Newtonian or the classical mechanism, we have to discuss this. Now, this is the, see this is a kinetics. This is the part. In this part, we shall study the effect of a force on the motion, and this is the discussion of a motion without considering the force. It is the branch of a kinematics, and this is the branch of a kinetics. Okay. Now, Newton's law, the Newton has formulated the 3 well-known laws of motion, well-known laws of motion, which give the relation between force and motion. Force and motion. See this, and these laws governs the Newtonian or the classical dynamics. Now students, अभी जो भी स्टूडेंट्स नेहा मिसाल Pranita, Sweta, Sagar, Asriya Gorte, now you tell me, you know that you have studied the Newton's laws of motion, you have studied in the physics also. Now you can tell me what is the Newton's first law. Now see this, the main concept is there is a relation between force. If we exert some force, suppose this is a rigid body, if we exert some force on that rigid body, then this rigid body will become in the motion. That means there is a relation between force and motion, and which is firstly discussed in the Newtonian mechanics by the famous scientist, that is Newton. And it gives three different laws, three different relations in between motion and force, and that are called as Newton's laws of motion. And the first Newton law, now Newton's, there are three different laws, Newton's laws of motion. त्यामध्ये Newton's first law, law first, we shall discuss the law first. Law first, what is that law first? Every action and reaction. Okay, Rutu Harshada Joshi, actually this is the third law, action and reaction. This is the third law. Now what is the first law of Newton's first law of motion? First of all, I express this. Every body continues, see this, Newton's first law of motion, every body continues in a state of rest or uniform motion in a line, except in so far it is compelled by the impressed force to change the state. See this, suppose this is a rigid body, suppose this is a rigid body. If this rigid body is at the rest, it remains at rest until external force exert on it. Or suppose in the universe, if a body is in motion, then it remains continuous in a motion, in a straight line or in a linear motion, until the external force exert on it, until the external force exert on it. This is the Newton's first law of motion. अभी देखो यह क्या कहता है न्यूटन्स फर्स्ट लॉ. अगर कौन सी भी रिजिड बॉडी है, वो किसी एक जगह पे है, रेस्ट में है, तो वो रेस्ट में ही रहती है जब तक उस पे किसी एक्सटर्नल फोर्स को एग्जर्ट नहीं होता है, तब तक वो रेस्ट में रहते हैं. या और अगर कौन सी भी बॉडी मोशन में है, कंटिन्यूअस इन मोशन में है in the universe, suppose, then it remains continuous in the linear motion until external force exert on it. यहाँ पे आप जो भी मून है, सन है, ये जो अर्थ है, ये जो प्लैनेट्स है, वो कंटिन्यूअस मोशन में रहते हैं. See this, they are in a continuous, in the linear motion. Why? Because it satisfies the Newton's first law. Because according to the Newton's first law, If there is no any external force exert on the body, then it remains at rest or continues in the straight line or in a motion. Okay, we shall write this. Okay, बरोबर आहे. नेहा जाधव, ऋतुजा, कृष्णा आले, very good. Rupali Dabekar, Pratiksha Kalseti, very nice. You have correct given correct answer. So I shall take one for screenshot who have give the answer. मी त्या विद्यार्थ्यांची एक स्क्रीनशॉट घेतो ज्यांनी आन्सर दिलेले आहेत. 1 minute. Okay, so I shall write the Newton's first law. एक मिनिट, न्यूटन्स फर्स्ट लॉ आपण या ठिकाणी स्टडी करू. या ठिकाणी न्यूटन्स फर्स्ट लॉ लिहित असताना I shall write this Newton's first law. See, every body continues in a state of rest or uniform motion in a line except in so far as it is compelled by impressed force, compelled by, see this, continues in state of rest or impressed forces to change the state. Impressed forces to change the state. See, this is the first law of Newton's law of motion. This is the first law first. Every body continues in a state of rest or uniform motion in a line except so far as it is compelled by impressed force to change the state. Okay, see, this is the first law of motion. Now we shall discuss the second law. What is that second law here? Second law, law second. Newton's second law or law second. Chala re, who can tell me which is the second law? Write down. Students, you try to write the Newton's second law in the chat box. I think it may be correct, wrong, but you have to try. Now Newton's second law tells us that, now I shall define the Newton's second law. The rate of change of momentum is proportional to the impressed force and takes place in the direction of the line of action of the force. See this, rate of change of linear momentum. What is meant by linear momentum? Actually linear momentum is the product of mass into velocity. So the rate of a change of a linear momentum, see this is a linear momentum of a particle. Now this is suppose a linear momentum. The change of linear momentum of a particle which is directly proportional to the impressed force. This is a main second law, and it is in the direction of the line of action of the force. So we shall write the second Newton's second law. You must write this, the rate of change of of momentum is directly proportional to the impressed force. This is the main law. The rate of a change of a linear momentum is directly proportional to the impressed force. See this. And it takes place in the direction of a line in which the force act. See this is the Newton's second law. You must know all these three laws very well. First law tells us the state of motion of the particle. Second law says that the linear momentum is directly proportional to the impressed force. This is the Newton's second law. चला रे स्टूडेंट्स, नाउ थर्ड लॉ सांगा बरे स्टूडेंट्स, कोण कोण आहेत ते थर्ड लॉ सांगा. हु कॅन टेल मी द न्यूटन्स थर्ड लॉ? यू टेल मी द न्यूटन्स थर्ड लॉ. प्रणित मुळे, व्हेरी गुड. न्यूटन्स थर्ड लॉ खूप इजी आहे. नाउ थर्ड लॉ 3. Newton's third law. This is the simple action and reaction. See this, actions and reactions are equal in opposite. This is the simplest law. अगर हम suppose this is a rigid body, if we act some force on that rigid body, then simultaneously this rigid body also act opposite force on that. Suppose this is a one particle on that body. See this, every actions there is a equal and opposite reactions. So Newton's law, third law, which is depend on action and reaction of the body or force. Okay, now actions and reactions are equal and opposite. Say this, action and reactions are, very good, फलक पठाण, नेहा जाधव, स्वाती गावकरे, अंजली कांबळे, ऋतुजा महाजन, साक्षी कदम, कृष्णा आले, सारिका शिवनगे. You have defined Newton's third law very well. Actually आपने बहुत अच्छी तरह से न्यूटन्स थर्ड लॉ को डिफाइन किया है. दैट इज एवरी एक्शन. You can define this Newton's law, third law, in this way also. Every action there is a equal and opposite reaction. Every action there is a equal and opposite reaction. See this, if we act, see this, if we act some force on this rigid body due to this pain, then simultaneously this rigid body is also opposite force on that first, that is on the pain. So there is a condition, action and reactions are equal and opposite. This is the very important Newton's third law. This is a very important Newton's third law. Okay, Shraddha Jadhav. Okay, very good. These are the three Newton's laws of motion. And see that these three Newton's laws of motions discuss or gave the relation between force and motion. What is the Newton's laws of motion? Actually, the Newton's laws of motion gave the relation between द फोर्स अँड मोशन. ओके, म्हणजे या ठिकाणी न्यूटन्स लॉज ऑफ मोशन आपल्याला रिलेशन बिटवीन कशात देतात, फोर्स आणि मोशनमध्ये. म्हणजे कुणी जरी तुम्हाला क्वेश्चन एखादा केला, व्हॉट इज मीन बाय न्यूटन्स लॉज ऑफ अ मोशन, what is mean by Newton's laws of motion? That means these are the laws which gives relation between force and motion. So you must say Newton's laws are the relation which gives the relation between force and motion, that are defined in three different way. So first way is called as a Newton's first law. Everybody continues in a state of rest or uniform motion in a line. Then 1 minute, एक minute रे. This is the Newton's law, first law. Every body continues in a state of rest or uniform motion in a line except so far as it is compelled by impressed force to change the state. Second law tells us that the rate of change of linear momentum is directly proportional to the impressed force, and it takes place in the direction of a line of action of the force. Now third law, action and reaction are equal and opposite. Now we shall discuss the deductions here. Now deductions. Now we shall discuss the different here, some important, 1 minute. Now some important deductions of the Newton's laws of motion. Deductions of Newton's laws of motion. See this is a conclusion, deduction from the Newton's laws of motion. See this. Now we shall discuss one by one the deduction. What is the deduction? Deduction means some results. हर्षदा जोशी काय म्हणते, डिडक्शन. डिडक्शन मीन्स सम रिझल्ट्स, सम कन्क्लुजन्स which are obtained from the Newton's laws of motion. Actually Newton defined three different laws, but these are not only laws which gives different results also. These laws gives different results, different conclusions, and that conclusions, that outcomes are called as deductions. So some important deductions from the Newton's laws of motion. So we shall write the deductions from the Newton's first law. Deductions from the Newton's first law. See this. I shall write, actually this is the theoretical part but conceptual part. See this law first. Inertia of a rest implies that if a body is at rest, it remains at rest, and inertia of a motion. See this. We shall write the deduction from Newton's first law. First deduction, see this. The inertia of rest implies that if the body is at rest, comma, it remains at rest. This is the concept of rest which is given by the Newton's first law. This conclusion occurs from the Newton's first law. The inertia of rest, the nature of the rest of a body implies that if a body is at rest, then it remains rest. Now second deduction, अभी हम second deduction की तरफ बढ़ते हैं. दूसरा deduction, what? Inertia of a motion, the inertia of motion state that if a body is in motion, if a body is in motion, it remains moving with uniform velocity. It remains moving with uniform velocity. This is the second deduction, second conclusion which we can obtain from the Newton's first law. This is the deduction first. The inertia of rest implies the body remains at the rest. Second conclusion, the inertia of a motion state that if a body is in uniform motion, then it remains in the motion with uniform velocity. Moving with the uniform velocity in a line. In a line. For, see this, in a line for all times. म्हणजे पहा, स्पेसमध्ये जर एखादी बॉडी जर मोशनमध्ये असेल तर ते एका स्ट्रेट लाईनमध्ये कंटिन्युअसली काय असते, मोशनमध्येच असते, एका स्ट्रेट लाईनमध्येच असते. लक्षात आलं का? तुम्हाला वाटेल मग अर्थ भोवती, सपोज दिस इज अर्थ अँड मून इज रिव्हॉल्विंग अराउंड द अर्थ. It is not in a straight line, which is in the suppose circular path or elliptical path, whatever may be, but it is not in straight line. Why this position occurs in the form of a motion of the moon? Because there exists some force from the earth on the moon, so it is in the circular path. Roughly we can say that it is in the circular path or the elliptical motion. Okay, so this is the concept. अगर किसी भी बॉडी पे अगर एक्सटर्नल फोर्स एक्सर्ट नहीं होता है तो वो बॉडी कंटिन्यूअसली यूनिफॉर्म मोशन में स्ट्रेट लाइन में ही यूनिफॉर्म मोशन में होती है. सो दिस इज द inertia of a motion. Now next, third conclusion, see this, the force is that which changes the state of inertia. So according to the Newton's first law, we can say that there is one quantity, that quantity is a force, and force changes the state of a motion of a बॉडी. चला रे स्टुडंट्स, फोर्सची आता डेफिनेशन सांगा. मग न्यूटन्स फर्स्ट लॉ वरनं एक डिडक्शन झाला, कन्क्लुजन झाला, वी कॅन डिफाईन द फोर्स, कन्सेप्ट ऑफ अ फोर्स. चला सांगा रे स्टुडंट्स, यू राईट डाऊन व्हॉट इज द कन्सेप्ट ऑफ अ फोर्स. फोर्स इज द डिडक्शन ऑफ, डेफिनेशन ऑफ द फोर्स, concept of the force, which is the deduction of the Newton's second law, sorry, Newton's first law. That means we can define from the Newton's first law, we can define the force. So we can write the deduction. So from this Newton's first law, we can define the force. Thus the first law of a motion gives the first law of a motion gives the definition of force. Due to this Newton's first law, we can define the concept of a force, we can define the force. And how to define this force? According to the Newton's first law, we can write the definition of the force: the quantity which changes the state of motion of a rigid body. So, the force is a quantity which changes the state of inertia of a body. See this, these are the deductions of, deduction means conclusions, that means outcomes, that means the terminology we can obtain from the Newton's first law. So, some important deductions now we have to discuss, which are obtained from the Newton's laws of motion. There are 3 Newton's laws of motion, so we have to write the deduction from first law, deduction from second law, deduction from third law. See this, actually the first law tells us that every body continues in a state of rest or in a uniform motion in a line, except in so far it is compelled by, see this, it is compelled by impressed force to change the state. This is the Newton's first law, and by using this Newton's first law we can write these 5 different deductions. मेन सम इम्पॉर्टेंट, यहाँ पे हमें खाली इम्पॉर्टेंट डिडक्शन लिखना है, नहीं तो बहुत सारे डिडक्शंस we can obtain from the Newton's first law. We can obtain number of deductions which are very applicable in the theory of mechanics, which can be obtained from the Newton's first law. Okay, number of systems nowadays in the space, in the satellite systems, we can use the Newton's laws of motions, and these deductions are applicable there. So, some important deductions we are writing here, only some important deductions which are obtained from the Newton's laws of motion. Now, these are the 5 main deductions of Newton's laws of first law of motion, and that deductions are these. The inertia of rest implies that if the body is at rest, then it remains at rest. Second, Newton's second law tells us that if the inertia of a motion states that if a body is in motion, then it remains moving with the uniform velocity in a line for all times, until external force does exert on it. Third, the force is that from Newton's first law there is one concept appears, and that compares that term is force. The force is that which changes the state of inertia. Now, the first motion gives, see this, the first of motion, sorry, यहाँ पे थोड़ा कुछ तो लिखना हो गया. The first law of motion, Newton's first law of motion gives the definition of the force. From this Newton's first law we can define the concept of force. So, we can write this force, the force is a quantity which changes the state of inertia of the body. Okay, these are the basic 5 deductions from the Newton's first law. You must know all these things. Now, we shall stop here. नो वी शॅल स्टॉप हिअर. ओके, ठीक आहे. आता सेकंड लॉचे डिडक्शन्स वगैरे आपण उद्याच्या लेक्चरमध्ये घेऊ. इथं या ठिकाणी आपण थांबू. नमस्कार, गुड बाय.